guys, 1.1c. Today we're going to talk about both degrees and radians. So I want you to think about the terms complementary angles and supplementary angles. You've heard those before in geometry. If you remember correctly, complementary angles are two angles that add up to 90 degrees. And supplementary are two angles that add up to 180 degrees. The way I remember that also is C comes before S alphabetically, 90 comes before 180. Now that's degrees, so what is that in radians? Remember 90 degrees is the same as a half a pi in radians, and 180 degrees is the same as pi in radians. Now, the difference with trig is that both angles have to be positive. So we are not talking about negative angles today. Both angles have to be positive. And that is going to be the hard part for this lesson, is remembering that part. So same thing over here, angles have to be both positive. So if I asked you to find complementary and supplementary angles for 60 degrees, okay, complementary are two angles that add up to 60, so 90 take away 60 is 30 degrees. And the supplementary angle is going to be 180, take away 60, or 120 degrees. Okay? Now, what if I asked you to find the complementary and supplementary angle to 200 degrees? Well, something plus 200 isn't going to give me 90 degrees, and something plus 200 isn't going to give me 180 degrees. So in this case, it is not possible. There is no complement or no supplementary angle. Okay? We cannot use negatives. On your own, pause the video after you tell me the complementary and supplementary angle to 120 degrees. So we need two angles that add up to 90 degrees. The only one that would work here would be like a negative 30. And remember, we can't have a negative, so there is no complementary angle. However, what plus 120 gives us 180? And that would be 60 degrees. So there is a supplementary angle, but no complementary angle. So that can happen. Okay? That should make sense with degrees, but what does it look like with radians? Well, if I asked you to find the complementary and supplementary angle to pi over 6, so basically what plus pi over 6 for our complementary angle is going to give us, pi over 6 is going to give us half a pi. For our supplementary angle, what plus pi over 6 is going to give us a full pi. Now, when we're talking about adding fractions, we have to have common denominators. So, this is like saying 1/6, and 1 pi is the same as 6/6. So, 5/6 plus 1/6 gives us 6/6. And then I'm just going to throw the pi symbol on there. So the supplementary is a little bit easier to see, so that's why I started with that one first. If we're in 6, half a pi is the same as 3/6, because 3/6 reduces to 1/2. So now that should help you. 1/6 plus what gives me 3/6? And that would be 2/6 pi. However, instead of leaving it as 2/6, we should reduce that to 1/3 pi, or pi over 3. So radians is a little bit harder because we have to deal with fractions. Okay? Alright, what if I asked you to find the complementary and supplementary angle to 2. Now, remember we talked about if you do not see a degree symbol, this is the same as 2 radians. Now, if you think back to yesterday's assignment, radians is pi over 2, pi, 3 pi over 2, and back to 0 pi or 2 pi. We also talked about pi is the same as 3.14. So that is radians. We talked about half a pi as 1.57 in radians. So if you think about 2 radians, if I sketched it, it would be right about here. So is there a complementary angle? Complementary angles are 2 angles that add up to a half a pi. Well, I'm already past a half a pi. So complementary, there is none. However, supplementary angles are 2 angles that add up to 180 degrees or pi or 3.14. So what is this angle right in here? 3.14 minus 2 or 1.14. So 2 plus 1.14 gives us 3.14. So the supplementary is 1.14 radians. The second part of this assignment or this lesson is converting degrees to radians or radians to degrees. Now, the conversion factor basically is going to be used both times. It just depends on which way we use it. The conversion factor is pi equals 180 degrees. Okay? So in this first example here, if I'm converting 135 degrees into radians, I'm going to use the conversion factor either pi over 180 or 180 degrees over pi. And the one that you pick is the one you're trying to get rid of. They need to be one on the top and one on the bottom. So if this is a fraction, I'm going to multiply, because this has degrees on top, I need my degrees to go on the bottom. So I'm going to pick this one right here, pi over 180 degrees. Because now that I have a degree on top and a degree on the bottom, they cancel with each other. And now I multiply straight across. 135 times pi over 1 times 180. Now, of course, we want to reduce our fractions. So both of these are divisible by 5, and then they're both divisible again by 9, and I get 3 pi over 4. Now, if you're using the calculators that you used back in middle school, you could enter in 135 over 180 as a fraction and hit the enter key, and it'll reduce it for you all the way. Just ignore the pi key. So go ahead and try this one. Convert negative 540 degrees into radians. So again, I want to get rid of degrees. So degrees is going to go on the bottom. Pi will go on the top. If I have degrees on top and degrees on the bottom, they cancel, and I have negative 540 pi over 180. Both of these are divisible by 10. And if you take it one step further, negative 54 divided by 18 is negative 3. So did you notice that I've basically been ignoring the pi symbol? I've just been working with the fractions and reducing. Now, what if we want to convert radians to degrees? It's going to be the same process. This time, we're going to use the degree or the conversion factor opposite. So notice here, if I'm converting negative half a pi to degrees, This time, what do I have on top? I have a pi on top. So this time, I want pi to be on the bottom and the 180 degrees to be on top. So it's the same conversion factor I used up here, but I wanted degrees on top and degrees on the bottom. Now I want pi on top and pi on the bottom, because watch what's going to happen with my pi's. If I have a pi on the top and a pi on the bottom, they cancel. And this is just like having a 1 there. So now I have negative 1 times 180 degrees over 2 times 1, which is 2, and negative 180 degrees divided by 2 is negative 90 degrees. Let's try another one. Let's convert 9 pi over 2. Again, I have a pi on the top, so I want to get rid of it by putting a pi on the bottom and the 180 degrees on top. Pi on the top, pi on the bottom, cancel. And now I'm going to multiply straight across 9 times 180 over 2. And now I can divide and I get 810 degrees. Alright, you try this one on your own. What does 3 pi over 4 convert to in degrees? Again, I'm going to put pi on the bottom, 180 degrees on top. If I have a pi on top and a pi on the bottom, they cancel. 3 times 180 and 4 times 1. And this gives me, I'm going to need my calculator here. Hopefully you ended up with 135 degrees. So that's it for today's lesson. Going from degrees to radians and radians to degrees doesn't seem to be as difficult as the complementary and supplementary angles. So I'll make sure we go through questions like that in class tomorrow.